So today we're going to start study about the multiplexer. Okay. So multiplexer is just like a data selector. Its another name is data selector. Multiplexer is a kind of combinational circuit. Okay. Basically there are two types of circuits. One is the sequential circuit and another one is the combinational circuit. Okay. So in the sequential circuit, one input, then output will goes to the another input. Okay, then its output will become the input of another like that in a sequence. That is the example. In that example of sequential circuit is the flip-flop. Clear? But in the combinational circuit, we are having a simple circuit. In this, we'll give some output, and according to that, we'll get some output. In this, there is a no sequence. Clear? So in multiplexer, basically we are having n is to 1 multiplexer. N is to 1 means we are having number of inputs. Okay? We are having number of inputs, but output will be only 1. Output here is denoted by y and input here is denoted by, we can denote it by d0, d1, d2 and so on. It goes up to d of n minus 1. Okay? Yeah. Suppose if I'll give you an example, because it starts from d0 na, and there is a multiplexer of, like, it would be 2 raised power 1, then 2 raised power 2, then 2 raised power 3, then 2 raised power 4. Means we are having the multiplexer of 2 is to 1. Okay. We are having the multiplexer of 2 raised power 2 is 4. So we are having the multiplexer of 4 is to 1. Then 2 raised power 3 is 8. So we are having the multiplexer of 8 is to 1. Or we are having the multiplexer of 16 is to 1. And then 2 raised power 5. Then we are having the multiplexer of 32 is to 1. Okay. Clear? But in this one shows the output, okay, and this one shows the input, right? So let's take first an example of 2 is to 1 multiplexer. So we'll write it here like 2 is to 1 mux. In short, we known as multiplexer is also known as mux. It's a short name of multiplexer. Okay. So two inputs means we are having 2 is to 1 multiplexer means two input, right? One input is D0 and another input is D1. As that you know that that would be n minus 1 na? I told you it is n is to 1 and that is last input is n minus 1, that is 2 minus 1. Okay, we got D1 and output is y. Okay, and but for that we are having one more thing, that is a select line. That is a select line. So how many are the select line? For that we are having one formula, that is 2 raised power m is equal to n. Okay, where m is the number of select line, n is the number of select line and n is the number of input. Okay, like suppose I'm taking one example of 2 raised power 3, like 8 is to 1 multiplexer. Okay, in 8 is to 1 multiplexer n is how much? 8, right? If we want to calculate the select line, then 2 raised power m is equal to 8, right? So m value is how much here? That is 2 raised power 3 is equal to 8, so m value is equal to 3. So in 8 is to 1 we are having how much select line? That is 3 select lines, right? Similarly for 2 raised by 4 or 16 is to 1, 16 is 2 raised by 4, so for 16 is to 1 how many select line we have? 4 select lines. Okay, clear this thing? So for 2 is to 1, how many select line will use? Only 1. Okay? Yeah, because 2 raised to power 1, so there is only one select line. That is denoted by S note. Okay? In digital, generally we don't start with the 1, we always start with the 0. Okay? 0, 1, 2, 3, 4, so on. Clear? So this is the basic block diagram of the 2 is to 1 multiplexer. Okay. Now what happens in the multiplexer? Like suppose I am giving you a journal example. Suppose you are having one Almira. Okay. And in Almira you have two boxes. Okay. One box is of t-shirt. Okay. Like one drawer is of t-shirt. In Almira you are having two drawer. One drawer is of t-shirt and one drawer is of jeans. Okay, means we are having two inputs, right? One your input is t-shirt, that you are putting t-shirt into your Almira. Another input is your jeans, that you are putting jeans into the Almira, right? But output is only one, right? Output is only one. So we have to select, like select line is also one. So if you will press 0, then t-shirt will come out. Okay. If you will select 1, then in that case jeans will come out. Like it's an automatic Almira. So you put t-shirt and jeans. Okay. If you like if you want to open the Almira, you have to be like you have to press 0 or 1. Okay. If you want t-shirt, then you will press 0. If you want jeans, then you will press 1. Okay. Clear this thing? So So in this basically, similarly, we'll draw a truth table related to this. Okay. In truth table, we are having one is output is denoted by Y, one is the select line, okay, and another is the enable pin. Here we also connect with the enable pin. Enable pin is always connected with every multiplexer. Okay. Now see what is the function of the enable pin. Enable is just like the MCB of your house. I am just relating. Like suppose this is your house, okay, and this is your room, and and in front of your house you put an MCB. You know now what is MCB? MCB is a miniature circuit breaker which is like you can pull down or pull up, right? That the electric circuit. So if your MCB is off, okay, if your MCB will is off, then will current enter into the house? Yes or no? No. If your MCB is off and you switch on the fan, will fan will work? Yes or no? No, MCB is off. Okay, MCB is off and you switch on the fan. So in that case, tell me, will fan will work? No. So off is, yeah, because MCB is off. So off will denoted by 0 in digital, as you know, and 1 is denoted by on in digital. Now what you do? You on the MCB, okay? Then in that case you on the fan, switch on the fan. Then in that case fan will work or not? Yes, in that case fan will work. Okay. So if we'll give enable pin to 1, okay, if enable pin is 1, then your multiplexer will work. Okay, if your enable pin is 0, then whatever input you will give, that output will always be 0. Then in that case your multiplexer will not work. Okay, so enable is 0, no working on multiplexer, no multiplexer work. Yeah, or we can say no mux work. Okay, if enable pin is 1, then only mux will work. Okay, clear? So we are having first enable pin is 0. Okay, select line can be 0 or can be 1. That is denoted by cross. Like if I'll say that it can be 0 or it can be 1. So that system is denoted by a cross. Okay, it can cross means the, or we can say like a it's a cross, or we can say don't care. Don't care represent it can be 0 or it can be 1. Okay, so if enable pin is 0, will output will come or not? If no, so output will be 0. Correct? In, then the second case, now we now enable pin is on. Okay, if enable pin is on, then we select 0. Okay, if we select 0, then first input will be selected. Okay, I told you that I gave you one example. This is D note and this is D1. If I'll select 0, then t-shirt will come, means D note will be the output, right? If I'll select 1 from this select line, then jeans means D1 will be the output, right? So if I'll say for this, if this is the enable pin 1, I'll select 0. For 0, the whatever the first input we have, that will be the output, that is D note. Okay, again then enable pin is 1, and if select pin is 1, okay, there is only one select pin, so either it can be 0 or it can be 1. So in that case, if I'll select 1, then second output is second input is D1. Okay, clear this thing? So this is basically the truth table of the 2 is to 1 multiplexer. Clear? Now we have to draw the expression from this truth table, like a boolean expression we can say, and after that we have to draw the logical gates from this expression. Okay, like see how can we draw the expression first. So output is what? Y, right? For this we don't take, for this we'll take is enable here. Okay, here in this case s is 0. I told you that if it is 0, that is denoted by a bar, right? 0 means like s bar, 1 means only s. Here the value of s is 0, so that is denoted by s bar, and the output here is d naught, so like we'll write down d naught. Plus then enable pin is 1, so we'll write down E. If enable, now S is 1, so we'll write down S as it is. Okay, and the output is how much? D1, right? Okay, enable pin is 1, so E. Select line is 0, so S bar, then output is D note. If select line is 1, then S. Okay, clear? If I'll solve this, then E would be S bar D naught plus S into D1 bar. Correct? Now what we need to do? We have to draw the logical gates using this expression. We got E S bar D naught plus S D1. Okay. We'll ignore the E enable because obviously it will be open in every case, then only multiplexer will work, right? So we have to draw the logical gate expression for this. Like suppose we are having one line S, okay, we need S bar also, so we'll use which gate to make it S bar? Not gate, so that would be S bar. Okay, again we'll use one line for D1. Okay, again one line for we'll use D note. As you can see, there are three input only, S, D note and D1, right? So as you can see that S bar and D note are multiplied. For multiplication we will use which gate? AND gate, right? So it would be this one, and this one would be denoted by AND gate. Then S and D1 are multiplied, means S line is this one and D1 line is this one. So it would be again AND gate, right? And these are added with each other. So for addition, we will use which gate? OR gate. Correct? So this is the output Y. Okay? Clear this thing?